Welcome to AskPrep, your trusted companion for NEET and JEE preparation. Today we will study about a very important topic of chemistry, which is chemical and ionic equilibrium, Le Chatelier's principle and pH. These concepts form the backbone of understanding energy changes in chemical reactions, which is crucial not only for your Class 11 exams but also for competitive exams like NEET and JEE. By the end of this video, you'll have a solid understanding of how these three concepts are connected and how they can be used to predict the spontaneity of reactions. Let's begin by talking about enthalpy, a term that is fundamental when studying energy changes in chemical reactions. Enthalpy is essentially the total heat content of a system at constant pressure. It's a state function, meaning it only depends on the initial and final states of the system and not on how the system got from one state to another. In simpler terms, enthalpy tells us how much heat is absorbed or released during a chemical reaction when the pressure is constant. This is particularly important in reactions happening in open containers, like those you might encounter in everyday life or laboratory experiments. When we look at reactions, there are two main types in terms of heat exchange, exothermic and endothermic reactions. In exothermic reactions, heat is released into the surroundings, which means the system loses energy, and the enthalpy change, H, is negative. A common example of an exothermic reaction is the combustion of fuels, where heat is released. On the other hand, in endothermic reactions, heat is absorbed from the surroundings, and the system gains energy, which results in a positive enthalpy change, H. A good example of this would be the process of photosynthesis in plants. Understanding enthalpy is crucial because it allows us to understand how energy flows during chemical reactions. It helps us calculate how much energy will be needed to break bonds or how much energy will be released when new bonds form. This understanding also helps us predict the heat involved in industrial processes, like the creation of energy from burning fuels or the formation of new compounds in chemical manufacturing. Next, we move on to entropy, another fundamental concept in thermodynamics. Entropy is a measure of the disorder or randomness in a system. It tells us how much the energy in a system is spread out. The higher the entropy, the more disordered and spread out the energy is. Entropy is an important concept because, in any spontaneous process, the total entropy of the system and its surroundings must increase. This idea is based on the second law of thermodynamics, which states that the entropy of the universe always tends to increase. To understand entropy better, let's think about a simple example. Imagine you have a container with gas molecules all in one corner. Over time, the molecules will spread out to fill the entire container. As the molecules move from a highly ordered state to a more disordered state, the entropy of the system increases. The greater the number of possible arrangements the particles can have, the greater the entropy. This is why gases have higher entropy than solids or liquids, because their molecules are more free to move around and spread out. Now, while entropy may seem like a measure of disorder, it's important to remember that in a chemical reaction, entropy is a driving force. If a reaction leads to an increase in entropy, it will naturally tend to happen spontaneously. This is why reactions like the melting of ice or the evaporation of water, which increase disorder, are spontaneous processes at certain temperatures. Finally, we come to Gibbs free energy which brings together enthalpy and entropy to predict whether a reaction will occur spontaneously. Gibbs free energy is a thermodynamic potential that helps us understand the energy available to do useful work in a reaction. The key idea behind Gibbs free energy is that for a reaction to be spontaneous, it must decrease the system's free energy. The change in Gibbs free energy, G, is determined by both the change in enthalpy, H, and the change in entropy, S. Essentially, Gibbs free energy is a combination of the heat energy and the entropy change that occurs during a reaction. A negative value of G indicates that the reaction will be spontaneous, while a positive value of G means the reaction is non-spontaneous under the given conditions. But here's the interesting part, Gibbs free energy doesn't just tell us whether a reaction is spontaneous or not. It also tells us about the extent of spontaneity. For example, if the value of G is negative and large, it means the reaction will occur spontaneously with a significant release of energy. If G is negative but small, the reaction is still spontaneous, but the energy released will be minimal. One important thing to note is that the spontaneity of a reaction depends on both temperature and the specific nature of the reactants and products. For some reactions, increasing the temperature might make a reaction more spontaneous, while for others, it might have the opposite effect. By understanding how to interpret the values of H, S, and G, we can predict not just whether a reaction will occur, but also how much energy will be involved and how the system's disorder will change during the reaction. This knowledge is incredibly useful in various fields, from chemistry and physics to engineering and environmental science. In industries, understanding thermodynamic principles helps optimize reactions, design better energy-efficient processes, and even control the reaction conditions to improve yield and efficiency. In summary, thermodynamics is the study of energy changes, and understanding concepts like enthalpy, entropy, and Gibbs free energy is essential for predicting the behavior of chemical reactions. Enthalpy helps us understand the heat involved, entropy gives us insight into the disorder, and Gibbs free energy tells us whether a reaction is spontaneous. Together, these concepts form the foundation of thermodynamics, and mastering them is crucial for both your 11th grade chemistry exams and competitive exams like NEET and JEE. Thank you. We hope this video has helped clarify these concepts and made thermodynamics a bit more approachable. If you found this content helpful, don't forget to like, share, and subscribe to AskPrep for more in-depth lessons on chemistry and other subjects. Keep practicing, stay focused, and good luck with your studies.